the last thing we're talking about in this section is just how bonds can be polar and what's called nonpolar, and how electronegativity has to do with that. So we really have three things that we focus on. The first one is called nonpolar covalent, or you may hear it as NPC. But nonpolar covalent means that you are covalent, so you're sharing. And if you're nonpolar, that means you are equal. So you do not have poles. There's not like one end that's better than the other. We also have polar covalent, which again is covalent, so we're sharing. But now because we are polar, we are unequal. And then our last one is ionic, which is kind of like extreme unsharing, because you actually take one. So one element takes an electron or electrons from another element. When you're polar covalent or ionic, basically what you have is you have a side that's very positive, well, slightly positive, and a side that's slightly negative. And when you have that, it's called a dipole. And if you think about, like, we have our magnetic poles, and it's the exact same kind of thing. It's a magnetic situation. And this is an example of one that is polar. Hydrogen fluoride's exceptionally polar. And what happens is one of the elements is going to pull the electrons towards it, and it gets this delta negative sign showing that it's pulling the negative electrons towards it. And then the hydrogen doesn't pull electrons towards it. It kind of like doesn't have a very good grasp on them. So he becomes somewhat positive, and he gets a delta positive, indicating that. The easiest way to tell this is electronegativity. There is a chart in the end of your notes that has like pictures and they're like little circles, and it tells you the electronegativities. So that's in your notes, or should be. And basically, when you're saying something's electronegativity, it's how can it pull electrons towards itself. And it's a scale from 0 to 4. And your differences are going to indicate whether you're polar, nonpolar, or ionic. And you can see down here, there's not distinct differences for most of them. There is a little bleed over. So what you do is you look up your electronegativity of them both, you subtract them, and then you see where you fall in here. So we're going to do a couple, and then we're done. So again, you have to look it up on your periodic table that has little ones here. But this one we're doing hydrogen to hydrogen. So what you need to do is you need to look up the electronegativity of hydrogen. And when you do that, you should get 2.1. Now they're both hydrogen, so they're both 2.1. So you're subtracting them from each other. But so this one's going to look like 2.1 minus 2.1. And obviously you get 0. There's no difference. They're exactly the same electronegativity because they're the same element. So if you look at your chart, we're over here at the 0, and it's clearly indicating that this is a nonpolar covalent compound. So hydrogen gas is nonpolar covalent. When you look up hydrogen and fluorine, you'll find your different ones. Hydrogen is 2.1, fluorine is 4. You always just want to take the higher number minus the lower number. So we do 4 minus 2.1, and we get 1.9. You refer back to your chart, and you see we're kind of in this bleed over area. So then you have to actually look at your compound and see what do you have. This is 2 nonmetals. So this would be considered polar covalent rather than ionic because of the nonmetals. And then our last one here, again, hydrogen is 2.1, bromine is 2.8, and again, it's just off a chart. And what you'll notice is the further apart you are in the periodic table, the larger the difference is, so you can kind of gauge from there as well. But if we subtract 2.8 minus 2.1, we're going to get 0.7. And if you look that up, we're right in the smack dab middle of polar covalent. So this guy is polar covalent. So that's one way of just figuring out something. I mean, you can look at the thing and inherently see it. If you're dealing with the same elements, you're always going to be nonpolar covalent. If you're dealing with nonmetals, typically you're going to be polar covalent to some extent. And if you're dealing with metals and nonmetals, then you're typically ionic.